Hello, statistics student. This video is for um, OnlineStatbook Inverse Normal Calculator how-to. So we'll show you how to find the cutoff. So inverse normal calculator is not for finding probability of a normal outcome, but find the cutoff value that corresponds to a given percentage, either above or below that particular cutoff. Okay, so the first is when we are doing standard normal, Z, right? So to find cutoff where the Z cutoff where the left area is 12%. So left is on the low end side. So we don't know actually how much it would be for it to be 12% in terms of area. So we can just, kind of uh, guess what it is. So we would say we would highlight the cutoff for the left area. So you would say, okay, so just pretend this is it. This area is 12%. We want to find this Z equal to what, right? So this area 12% is here, 0.12. So first of all, you have to say the area of 12% in decimal is 0.12. So you would go to online inverse normal calculator. So the way you do it is you Google inverse normal calculator. The first one should be fine. It's related to OnlineStatbook. So now you have to give the area, which is 0.12, because you have to have an area first. And then you have to tell them the mean and standard deviation. For standard normal is 0 and 1. By default, they have the above click, but you are looking for below in this case, right? Because you see how before you actually go to the calculator, you highlight it first. So you click below, and that's right. And then you recalculate is negative 1.175. So you will copy the answer down. You will say, okay, the cutoff is negative 1.175. That means for Z greater than negative 1.75, that's 12%. No, not greater, less than negative 1.175, that's 12%. So that's the first one. The second one is find the cutoff for a right area of 6%. Right is on this side, so 6% is really small. So you just, it's hard to tell exactly what it is because you are actually trying to find the cutoff, so you don't know what it is, but you know that the right area is 6%. So right area doesn't have to be a tail. It could be really big, and that's just shade on this side. So how do I know if it's this tail or like all the way above? What you can do is, the middle is 50%, right? So if it's less than 50%, it would be, a tail. If it's more than 50%, then you would say it's on the other side, but tail that side. So, but right area 6%, then I would go to the inverse normal calculator. And then I say the area is 0.06. It's not 0.6. Okay, 0.1, and it's above. So you click and recalculate. It's 1.55. So then you would say Z cutoff is 1.55. So any Z that is more than 1.55, there is 6%. That is 6% of the total. What about cutoff for the top 6%? That is the same as that, right? So when they say top, that is the highest number. So that means this is 6%, and we already did that. That would be use above, right? Use above. And then the area is 0.06. And so it should be the same 1.55. So sometimes they use right area, then sometimes they use top. What about cutoff for the bottom 20%? Bottom is on the low end, right? So that means 20% is a little bigger, so you can do more. You say this is 0.2, right? 20% is 0.2. So you find Z equal to what? Like that. So of course that would be 0.2 here. And then we want below, right? Negative 0.842. So this cutoff is actually Z equal to, so we do below, negative 0.842, like that. Okay. You can also do in between, right? So if you say, well, I know the total area in between here is 95% or something, you can also do that. So 0.95 in the middle. So we say be in between. So you would have two number, negative 1.96 and 1.96. So that is one way. I didn't put it down here, but yeah, you can do it that way also. Another one is when we're doing non-standard normal. So if it is non-standard normal, your mean is not 0 or standard deviation is not 1. So it will be 100 in this case. In this case, we're doing IQ is mean is 100, standard deviation is 15. And I want to do the cutoff for, let's type something. Maybe I will do a in between because last time I didn't do in between. So the cutoff for the middle, 95%, right? So we know cutoffs, right? We have two cutoff for the upper and lower so that the middle area is 95%. So we can do in between and then 0.95 and recalculate. So that would be 70.6 and 129.4 if we round to one decimal places. So for graphing, you would say, okay, so it would be middle 95%, right? So you do between. Area is 0.95. So the cutoff will be x1 and x2. x1 is 70.6. x2 is 129.4. So that's how you do between. Let's do the second one. The cutoff for the right area of 11%. So we would say area is 0.11. And then right would be on the high side, right? So it would be above, right? Then it is 118.4. So I can draw the picture first. So this is 0.11 and x is 118.4. Find the cutoff for a right area of 2.2%. Again, right area, but really small one, right? So only 0.022. 2.2% is 0.022. And I want to know the cutoff. Of course, we use above, right? The last one we also use above. And then you do 0.022 and then you do above and then evaluate or recalculate 130.2. So for 2% is 130.2. So 2% of IQ is greater than 130.2. Cutoff for the top 6%. Top, still top. Okay. So this is 6%. 0.06. What is this cutoff? So x would equal to, of course, we use above again, right? So this is on the high side. The high side we use above. Then we want 0.06. Then we do recalculate. So it's 123.3. 123.3. Last one is the cutoff for the bottom 20%. So bottom means in the low end, right? So here, so this is 20% is 0.2 and we want the cutoff. So do below, right? So yeah, a lot of time is above or below. What is the area? We want it to be 0.2 below, right? 87.4. So x would equal to 87.4. So all in all, the inverse normal calculator is used to find the cutoff if you are given either the left area or right area. If you have a left area, you use below. If you have a right area, you use above. Now, in all these examples that I give you, you seems to see that they're all like either on the left tail or right tail, but it is possible to say the left area, let's say, when the cutoff for left area of 76%, that's possible because that's actually the meaning of percentile. So left area, this is greater than 50%, right? So on the left side should be here, right? Really small, but half of it is already 50%, so your cutoff should be on the right side. So this is 76%. So if you are dealing with an area that's greater than 50%, so just imagine it won't be a small tail at the tail end. It would be over half of it and go to the other side. Now, when you do the inverse normal, you still say what? You still say below, right? You still below because all these are below this cutoff. The X cutoff that you have a left area of 76. So you do 0.76, but you would do below. Okay, and you do recalculate is 110.6. So X is equal to 110.6 is the answer. So if it is 110.6, that is this number is greater than 76% of all IQ data. Okay, and the same for right area. So if you say, oh, I have a right area of, this is really not very common, but what corresponds to a right area of, say, 80%? Right would be on the right side, right? So it's usually smaller than 50%. But if it is greater than 50%, that means this is the cutoff. So that on this right side, this is 80%, right? So so this would be you if you are to do the inverse normal calculator, you would use above because the 80% corresponds to anything that above this cutoff. Above means above the cutoff. So we can try 0.8 and then we say above 87.4. So x is equal to 87.4. You can see that this is the same as this one, right? X equal to 87.4. It's the same as the bottom 20%. Why? Because if it is corresponds to the top or right area of 20%, that is the same as having a bottom 20%. So these two are the same cutoff, but it corresponds to a right area using above as well as using below 20%. So you can do either way, but just be aware if the red area is greater than 50%, your number is not for left, your number is not on the left side, but it could be on the right side. So that's how you use the inverse normal calculator. So don't confuse this with using the normal calculator, which is used to find probability. Inverse normal calculator is you use to find cutoff value. And sometimes they give you left area, sometimes they give you right areas, and yeah, and sometimes they give you the in between area also. Okay, so that's all.